the unit, then we can do some exercise, and it should be good time for us to do something. And hopefully this will help you for doing the second portion of the homework. So this one is we consider an Earth satellite is in an orbit with the following information: perigee, altitude, and the ZP equal to 400 kilometers, and eccentricity. Okay, so here we have a few, we will see a few kind of the new terms, and let me define it for you. So you can see we are given two pieces of the information about the conic section, which is an elliptic orbit. So basically we should be able to derive everything else, and this is the exercise we're doing here. So we can see we're going to calculate, and the first one is the VP. Okay, so to do this one, I think it's very convenient for us to draw something, to draw the shape. So this is the orbit, and this is a perigee. And this is the Earth. And Earth has a radius. So this is the radius. Let me do that in a good way. So this is the radius of the Earth, RE. And what is the perigee altitude? Basically, that is measured from the surface of the Earth to where the satellites locate. So this is ZP. Okay. So therefore, from here, you can quickly see this is RP. RP simply is equal to RE, the radius of the Earth, and plus the ZP. Okay? Okay. So from here, we can take out all the information, get that information ready. So mu equal to 398,600 and kilometer. And I pick these numbers, okay? And if you, of course, if you want to be precise, you can take the whole numbers. Okay, and let me take this one. And then RP equal to RE plus ZP, and that is 6378, and plus 400, and that is 678. So again, the radius of the Earth, I just take to the digit, the first digit, and ignoring the things after the decimal point. So therefore, here we can calculate is this. To VP, how to do this one? We have RP, we have E, so we should be able to calculate all the information from the tables. And before I dig out the details, we see kind of brainstorming to see what we can do. So here we are given two information. Basically, we have RP. So here we're given two information, RP and E. So we can calculate is A, B, C, and even we like is RA, and even we can calculate P, right? So everything here we calculated, but nothing about that information we want to calculate. So how can we proceed? Maybe one hint is this. We know the P is defined by, can be related to h squared divided by nu, right? And also the h, we know h can be related to is Rp times Vp, right? So that is the one from the starting of the today, we have the connection between the orbits and counter sections. So here I just try to show you how to think, what is the thinking process for this one, and how to get the information from many pieces here. So probably this will be the good starting point. Okay, so as long as we look into the table, finding the P is equal to A times 1 minus E squared. And but here we are given Rp, so basically we try. So this could be the good link, and we see. Okay, so we have that one, but also on the other side we have, this is about the geometry. On the other side, we also have the orbit equation. Orbit equation we have is R equal to P 1 plus E times cosine through anomaly nu. So that is about the orbit. So this is about the geometry. Okay? Take care. So pretty much we can try to combine the two pieces of information together. So we can see. So my method, my approach is this. I will start with the orbit equation. So Rp by the orbit equation R equal to P and 1 plus E times cosine through anomaly nu. So at perigee, the nu equal to 0 because we measure the true anomaly from the perigee. So here the Rp equal to P and 1 plus E. Okay, and then we plug in informations. So here P equal to h squared divided by nu, 398600, and 1 plus E equal to 0.6. Okay, and also the Rp we simply calculated is 76998. If you wish, the first time you can keep all the units in your calculation, you can see what happens. But here, if we keep everything consistent, kilometers, seconds, and you keep everything consistent, basically the old units will be automatically coming out. So from here, we can determine h will be equal to 65750, and h is the distance squared by time. Okay, that is a constant. Okay, so once we have this one, then we can see this one h is also equal to Rp times Vp. So from here we can determine Vp. So therefore Vp equal to h divided by Rp, and Rp. So that one is 9.7 per second. Okay. Then the second one we can try. So again, you can see the tables we summarize in content section will be turned out very handy. So probably you can make your kind of your own card and bring everyone with you. The second one we want to determine is the RA, the apogee, radius. Okay, so RA, if you remember, equal to, again, this one can be derived from the tables in the content sections. So that is 1 minus E, 1 plus E. Okay? Because in the tables we have is RP equal to A, 1 minus E, and RA equal to A, 1 plus E. I use these relations and get the this equation here. So this one can be calculated. RP already been calculated, and E is 0.6 given. So therefore, this one is 2,7,112 kilometers. Okay. The third one, the 8, the semi-major axis. So again, A, what is A? The longest distance is 2A. 2A equal to RP plus RA. So therefore we can see A equal to 1/2 of RP plus RA. And we calculated RA and RP already, so that is 16940 kilometers. The first one is VA, the velocity and energy. So this one, again, here H equal to RA, VA. So therefore, we can calculate VA equal to H divided by RA. And RB just calculated earlier. So that is 2.425 kilometers per second. By the way, here I stop a few seconds. Here you can see the velocity at the apogee and 2.4 some kilometers per second. That is the slowest speed when the object is on the orbit. Y is the slowest speed, you should know, okay? And that is the fastest speed of the object on the orbit. So here you should have a common sense. For most of the satellites around the Earth, their speed is at the scale of the kilometer per second. And usually it's between the single digits. Sometimes it's to closing to double digit. Double digit should be 10 something. 20 to me is very fast. And that fast is that hit very close to the surface of the Earth. If further away from that one, then you expect this number should be reduced. But that is a common range of the Earthsat. Okay, so before we move on more, you must have this kind of things. So that will provide to you, if you do certain calculations, if you will be calculated, say the speed is 100 some, you double check your calculation. That shouldn't be that big, okay?